Welcome to ETL 512, Electronic Circuit Analysis. Today, we're going to look at an example of a bipolar junction transistor, or BJT, in the common collector configuration. We will go step by step. First setting up the circuit, then replacing the transistor with its hybrid pi model, and finally calculating the input impedance, the output impedance, and the voltage gain. Here are the parameters we are working with. VCC equals 15 volts, beta equals 100, RE equals 25 ohms, RBB prime equals 50 ohms, RC equals infinity. With these values, our job is to derive the equations, state any assumptions, and calculate the main amplifier characteristics. So step 1 is preparing the circuit for AC analysis. In AC analysis, we make 3 simplifications. First, we replace all capacitors with short circuits. Second, we set all bypassed elements to 0 if there are any. Third, we set the DC input source to 0. By doing this, we strip the circuit down to only the small signal model. Step 2 is to remove all bypassed elements from the circuit. This makes the circuit simpler and ready for substitution with the hybrid pi model. Step 3, we replace the transistor with the hybrid pi model. This model has a few parts. RBB prime, which is the base spreading resistance, in series with R.pi. At the input, R pi is equal to beta plus 1 multiplied by Re. At the output, we have a current-controlled current source between collector and emitter. Normally, we also add RC, which is the small signal resistance between collector and emitter. But here RC is infinity, so it can be ignored. Now, let's calculate the input impedance. The formula is RBB prime plus open bracket beta plus 1 close bracket times Re. So, 50 plus open bracket 100 plus 1 close bracket times 25. That gives 50 plus 2,525, which equals 2,575 ohms. Now, if there is an external emitter resistor, the total input impedance will be the parallel combination of that resistor with this value. For example, here we combine 680 ohms in parallel with 2,575 ohms. The result is about 24.57 ohms. So the input impedance is very low, which is typical for a common base amplifier. This page shows the same calculation but written differently. It says input impedance equals VBE divided by IBE. Expanding this, you can see that it becomes R pi plus RBB prime. So basically, it's the same result, just a different way of writing it. Next, the output impedance. Since RC is infinity, it has no effect. So the output impedance is simply equal to the collector resistor RC. That means Zout equals 3.9 kiloohms. Now, let's calculate the voltage gain. The definition is output voltage divided by input voltage. We start with Vout equals negative Gm times V.pi multiplied by RC parallel RL. Here Gm is the transconductance and V.pi is the voltage across R pi. We know that V.pi equals IB times R pi, so substituting that gives us negative G M times R pi times I to B multiplied by RC parallel RL. After simplification, the gain formula becomes negative Gm times R pi multiplied by open bracket RC parallel RL close bracket divided by Vn. Finally, let's put in the numbers. First, calculate R pi as beta plus 1 times Re. That's 100 plus 1 times 25, giving 2,525 ohms. Now substitute into the formula. After simplifying, we get the voltage gain equal to about 51.85. That means the amplifier provides roughly 52 times voltage gain in this common base configuration. Thank you, and see you in the next video.